It's nice to see that this room got so full so quickly. It's going to be interesting because the workshop I usually do at conferences is intended for 3 hours, so I had to cut it down to half the time. But we will see how that goes, especially with so many people. And someone who wanted to help me with questions not being here, so yeah, but we will manage. So, a real quick introduction. I'm Florian. Using Python since around 2011, originally to modify an electronic typewriter to write out tweets from Twitter, which was quite an interesting project. And at that point, I mainly programmed C and Bash scripts, and trying to parse HTML in Bash or C is not a good idea, so that's how I got into Python. In 2013, I started Qt browser, a Vim-like browser written in Python, which is still my main project today. And in 2015, I got into PyTest as part of the Adopt PyTest month, where PyTest maintainers helped projects to start using PyTest. I fell in love with it, started contributing, and somehow ended up as a maintainer of PyTest at some point. And gave PyTest courses at various EuroPython events, and also at various companies. So what will we cover in this course? First of all, how to install PyTest, which hopefully is something most of you already did by now. Then how to write tests with PyTest, how it avoids boilerplate, and what nice command line options there are, and some other basic features. Then a very big PyTest features, which are fixtures, to do setup and teardown of tests. Then we will take a quick look at how to run existing test suites and how to migrate to PyTest. We'll see an overview of what plugins there are. And if you still have some time left at the end, there will be an open space or just room for discussions and issues. So, if you have not a run, hopefully nowadays everyone should be using Python 3, because the year is almost over and then Python 2 is finally dead, or kind of dead. So if you have no Python 3 running yet, could you please raise your hand so we can get it sorted out? Good, no hand. So what I recommend is creating a virtual environment, because then you can play around with PyTest and plugins without affecting your system-wide installation. If you already have used virtualenv or venv before, could you please raise your hand? Cool, that's maybe 3/4 or so. So what virtualenv does, it just gives you a subfolder with a Python install in it. And whatever you do in that subfolder, whatever Python packages you install, are just contained in that folder. So you can play around, install different versions than what you have system-wide. And when you're done experimenting, you just delete that folder and everything is back to normal. So what you can do is install PyTest in a virtualenv or otherwise, whatever you prefer, and call pytest.h to print its help to see how things work. And if this doesn't work out for some reason, please raise your hands so we can see what's going on. In the meantime, I have some questions for you just to judge, just to know you a little bit better. Could you please raise your hand if you have written unit tests before? Okay, keep your hands up if you've written unit tests in Python. Okay, keep your hands up if you have written those with PyTest. Okay, cool. Now please raise your hands if you know what a decorator is. If you know what the yield statement is. Okay, cool. It's fine if you don't. I'll explain. No worries. So it looks like everyone has PyTest up and running. Awesome. Then we can get to the more interesting part. So what are the fundamental features of PyTest? PyTest tries to avoid boilerplate to make your tests as short and as readable as possible. It tries to give you useful information when a test fails. It allows you to parameterize tests, so you can have a single test run over several datasets or several arguments, for example. It allows you to have modular setup and tear down of things you need in tests using fixtures. And it's very customizable. So there are a lot of options to customize it to your needs and also a lot of third-party plugins. So the easiest way to run PyTest is to run PyTest. It used to be called PyTest in older versions, mostly for historical reasons, but then we got rid of that dot, which wasn't without controversy. But it's gone, so nowadays you can just call the PyTest tool. What you often see in PyTest projects are two files. conftest.py files, which have some global objects for the test suite. Things like fixtures or hooks, which we will look at later. And a pytest.ini file for configuration. So it's a more like declarative thing where you can say, for example, I like those command line options. I'd like you to, like if I run PyTest without any options, just act like those options would have been given. For example, for more verbose output, so you could always have verbose output without having to call it with -v or verbose. If you just run PyTest, it will run any tests it auto-discovers in the current directory, or you can also pass a file or a directory to it, and it does what you would expect. It collects all tests from there. So how does it discover tests exactly? It looks at any files starting with test underline prefix, so test underline anything .py. In there, it searches for functions and classes which start with test underline or test, and also any classes which derive from unitest.test class, so the standard unit test way of writing tests with the Python standard library. And something we see here and also we'll see later is that there is a bit of magic involved and even some concepts which might seem a little strange at first, but at the same time nobody came up with something better yet. So once you get used to those concepts, which might be a little weird, PyTest is something which is really easy to use. So how does that test code look with PyTest? Well, you have a function, you do something in there, and then you just use Python's assert statement to test things. So contrary to the unit test library, there is no things like self.assert equal or assert less or whatever. You just write whatever condition you would write with an if statement, for example, but use the assert statement to make your test assertions. You can use classes, but you don't have to, and many PyTest test suites just define free functions. So the main reason to use classes is just to group related tests. And there you don't need to inherit from anything. You just add a class as a test group, basically, and that's it. So, as I said, we have those kind of simplified assertions. For most things, there is a corresponding assertion in the unit test library, but still, I feel like that's the first big thing I noticed when migrating to PyTest. Oh, my assertions get so much nicer to read and to write. Because you don't really have that discrepancy of how you would write the statement ideally and how you need to write it for your test. You just use the assert statement. There's also something I've heard about PyTest, which is the best API is no API, which kind of is visible nicely here. But of course, there is a little bit of API in PyTest. For example, if you have an exception and you expect your code to throw that exception, for example, a zero division error here, there is a pytest.raises context manager. So you have this with block, and whatever is in that block, when that code is finished, or anything in that code that should raise that exception. Now, maybe if you're not used to this, you'd ask, well, how is that different from try except? And the difference is that code really needs to raise that exception. If it doesn't, your test will fail. Because you say, hey, I want to test that it does raise the exception. So now I'll show a quick demo. Of how a failure would look with PyTest. There's a file called failure demo, which just tries to show various different kind of failures. So what PyTest does is it again does some magic to be able to introspect what happens in the assert statement, and then shows you output like this. So it tells you your code called assert f equals g, those function calls, and that boils down to assert 42 equals 43, and that assertion failed. And if you have some more complex things, for example, if you're trying to compare strings, it tries to give you the difference between those strings and tries to make the output as nice and as obvious as possible. Because I think that's one of the main goals of a test runner, to show you where your errors are as obvious as possible, so you don't have to debug and don't have to dig down into them, but instead you just see what's going on. There are many more examples there. For example, if there's just one character difference, it tries to highlight that character, and so on. Or tries to skip if there are like, if you have a big data structure, like big string or a big list, it skips whatever is equal and only shows you, hey, there's a difference there at this position. So PyTest has a lot of command line options. I can't really cover all of them, so I'll just show some which I use almost daily. That's like one thing PyTest does as well is it captures all the standard output from your test. So if your test prints anything or your code under test prints anything, with the Python unit test you can't really do that because your terminal would get messed up with all those print output. But with PyTest, if you know in a test something is interesting, you could just print it, and PyTest will hide that output, but show it to you when the test fails. And with the -s option, you can tell it, hey, just disable that capturing, show me all the output, even of pausing tests. With -x, you can tell PyTest to exit instantly if there is some failure. You can use -k like keyword to filter with a given expression. So for example, only run the tests with whatever in their name, in the function name. And you can use --pdb to start the Python debugger on an error if you want to dig down into a test failure. So we'll start with the first little exercise. if you haven't downloaded the code yet, there's a URL here at the bottom where you will find some example code for future exercises. For these exercises, just write some test functions, play around with options a bit, create a failing test, and insert the print statement there so you can see the output capturing. Also, we have Raphael Piazzina here, or Hockebrot, who is working on PyTests as well, and Cookie Cutter mostly. He'll also help me, or help you if there are any issues. And feel free to ask, of course.
Do we have the slides?
Unfortunately, no, because the person who originally wrote them asked me not to share them. So I mean, it's been a while and I modified them a lot, but still I need to check first. Sorry. If you have a basic test running, you could also try to create a pytest.ini file, so a config file, where you persist one of those command line options. For example, -x. So whenever you run pytest, it always stops at the first failure. The pytest ini file should always be in the folder you run pytest in. So usually the root of your project. What you also see in some projects is that they use an existing config file like a tox.ini or a setup.cfg, where pytest also can read options from. But I personally prefer to have a separate file for pytest because then it's clear what file is for what purpose. Filters or marks, exactly. So the concept of those fixtures, it takes some time to get used to it. So if you feel lost now, if you feel like, okay, he's talking about fixtures, but what are those really? Please let me know and we'll try to clear things up. I'll just reproduce it for a second. So, let's just test fixture.py. Which is the same like on the slides. And if we call pytest with there's just fixtures there, it will show us the fixtures defined there. If that fixture has a docstring, like those strings at the top of a function you use in Python to document them, pytest would also show it here. And what you will see when you use skip inside a fixture, for example, something like this. So inside the fixture, we say, hey, we can't run this test for some reason. For example, if you add a fixture maybe for a database backend, and that backend isn't available, you could call skip inside the fixture. And then what you will see if we add another test function here, which uses that fixture, and now run pytest on it, it will skip both of those tests. So the gist of it is that a fixture can say, hey, I can't do this, I will skip this test. And whatever test is using that fixture will automatically be skipped. Because there is some kind of dependency, some kind of object it needs, which isn't available for whatever reason. PyTest, the reason you pass to the fixtures, PyTest doesn't print them by default, because in bigger test suites, you likely have a lot of skipped tests, or skipped or X-fail tests, but you can call it with -rs, like reason skipped. And then at the bottom it will tell you what tests were skipped and why, and from where. There are also other arguments to that or, like you could say, give me a summary also there again of all failed tests or of all X-failed tests or whatever. Depends on what letters you use after -r. So let's recap about what fixtures are. Fixtures are returned from a fixture function, so a Python function decorated with pytest.fixture. Each fixture has a name, which is the name of that function, and a test function can request or can use that fixture by having an argument with the same name. What we'll see next is how fixtures can be cached and how to do cleanup or tear down from fixtures. So sometimes we have something which takes some time to set up. Here we just use the time.sleep call, but it could also be a database or something else which just takes some time. Then maybe there is a good reason to say, okay, I don't want to set it up again for every single test. In an ideal world tests would be independent from each other, but sometimes we just can't help it. We have some dependency which takes some time, so we just want to set it up maybe once per test file or even once for the whole test session. So PyTest fixtures can do that as well. In that fixture decorator, we can pass a scope, which is the caching scope. By default, that is function. So the value is regenerated, or the fixture function is called again for every test function. Now take a look at the test fixture scope file. Modify that scope to module, which means it is cached and just generated once per test module, and take a look at how the runtime duration changes. You can also use the durations argument for PyTest to get some additional info, how time is being spent. What you should see is that your test takes 2 seconds without that caching. And if we edit that file to use scope module instead of scope function, PyTest caches that value for us, and it only takes 1 second. So the expensive setup only happened once, and PyTest then reused that value for all tests in the same module. So quite often, if we set up some kind of objects for tests, we also need to somehow clean things up again. Let's say for a database, maybe we would want to close the connection or roll back all changes after every test, maybe. So what we can do here, instead of returning a value, we use the yield keyword. Now, what the yield keyword is or does exactly doesn't really matter for you to use that feature. All you need to know is that it kind of returns a value which the test can use, but then after the test runs, the rest of the fixture function runs. So the setup here at the top runs before the test. Then here, where the yield statement is, the test runs, and anything after the yield statement is tear down, which runs after the test. Like it depends on the fixture scope if you have with a scope function, for example, where the value is regenerated for every test, then the teardown also runs after every test. If you have, for example, scope module, then before the test module runs, the setup runs, then the whole test module runs, and then after that, the teardown runs. And there are also some other scopes, like class for every test class, or session for the entire test session. Like if we have some print statements here in that A object. When it gets created, it prints A setup. When finish is called, it prints A teardown. Let's say we have 2 tests here. And now, if we run pytest on that file with -s to see the standard output, so it doesn't get captured, what we see is A setup, then in the test 1, teardown, setup again, in the test 2, teardown. Now if we would tell pytest to cache that value by using scope equals session, for example, and run it again, then we can see the value is set up once. PyTest uses it for both tests, and at the end, it is turned down. Now, one feature I don't want to get into too much detail about, but is useful to know, is that you can also parameterize a fixture. For example, if you have a database backend, and a fixture database, for example, and you know your code can run with, let's say, either MySQL or Postgres, or 2 different libraries, or that kind of situation. You can parameterize a fixture, and then all tests using that fixture will run twice. It will run once with database A and once with database B. And now that's the params syntax. I decided to move that out, to cut it out because of time reasons, but just so you understand what's going on here. And what you then can do to kind of compose those fixtures is that you would use a fixture in a test by having an argument named the same. You can also use the fixture inside another fixture. So there is another exercise file, test fix using fixed. Write a test function there using the answer2 fixture. Also parameterize answer2 to return 2 different values, similar to what we did above. Then run pytest with -v for verbose and see what tests or what combinations of tests are being run. What you should see when you write a test using that answer2 fixture and when we run that test, is that pytest runs it with the value 10 and 20. So we didn't parameterize the test itself. All we did is parameterize that fixture answer1. Now, if we now try to parameterize answer2 as well, let's say we have params 2 and 4 here. Now, parameterizing fixtures is the API for that is kind of weird in my opinion. Like the bad kind of weird, for once. You have a special request fixture, which is built into PyTest and gives you information about the test which requested that fixture. So you could also say, hey, print the name of the test which is running at the moment. But it's also used to access those parameters we use above. So if you parameterize the second fixture as well, so we have answer 1, which is 10 and 20, and answer 2, which is 2 and 4. And now run PyTest again. What happens is that PyTest runs all 4 combinations of those values. So, basically what I think you'd expect if you use 2 fixtures which are both parameterized. But I think the basic thing to take away is that you can use fixtures inside fixtures, which is quite nice to build up some kind of more complex structures. If you have some kind of object you need in your test, and that object needs another object, you just have a fixture for each thing you need, and then you combine them however you see fit. Now, how are those fixtures visible? What tests can use those fixtures? What's kind of special is that you don't need to import those. PyTest auto-discovers them just like it does with the tests. So whatever function you have decorated with that PyTest.fixture decorator, you can use immediately. Now, if you have a fixture method inside a class, it's only available in that class. If you have it in a module, likewise, it's available to all tests in the module. And if you have a conftest.py file somewhere in your directory tree, you can define a fixture there, and it's available to all tests in that directory and also all subdirectories. So that's kind of a nice way you can use to organize your fixtures inside your test suite. If you have plugins defining fixtures and that plugin gets loaded, the fixtures are available anywhere. So I want to quickly look at some built-in PyTest fixtures, which can be quite useful. PyTest can give you a fixture to create a temporary directory for each test. It gives you a fixture to temporarily modify external state, for example, patch some function away. And it gives you fixtures to influence the capturing, the output and logging capturing. So if you need to know what a function prints or what ends up in the log, you could use those. So what's the temp path fixture? Could you maybe raise your hand if you have used pathlib before from the standard library? Okay, that's more than I expected actually. So what pathlib is in the standard library, it gives you path objects. So instead that you use the os.path module with strings, you can use those objects. And for example, use the slash operator to chain paths together, and it will end up working on Windows and on other systems, because Windows uses backslashes for path separators. And for a long time, PyTest had something similar with the fixture called tempdir, but with its own kind of path objects, because pathlib was only added in Python 3.4, I believe. Nowadays there is another fixture temp path, which just uses pathlib and the pathlib API. So for consistency, I'd recommend always using that. But if you see tempdir in a test suite, it's kind of the same thing. So what it does, it gives you a temporary directory where you can, for example, create files, write stuff to them, and then use them in your test. There are people who believe you shouldn't do file system access inside a test. it's kind of not pure enough. I personally believe you shouldn't do network access, because then that will end up painful, because then the server is down and your test fails or whatever. But I think often file system access is okay and makes things easier, because it's just a temporary file on your file system. And what PyTest does, if you print the directory there, it keeps those around for a while. So if you run your test suite like 5 times, it keeps, like, I think the last 5 temporary directories it did for those tests. So if something fails with file inputs, or maybe with some temporary file or whatever, it's just there and they can inspect it and run things manually and see what's happening, which I find quite useful. Then there's the monkey patch fixture, which you can use to patch things away. Like I said before on the dependency injection slide, sometimes there are better measures, like passing in some object instead of creating it. But sometimes it's okay to patch things away. Then there's quite nice PyTest documentation about those fixtures, but the main things to use are setUtter, which allows to set an attribute and patch it away, and setEnv, which allows you to set an environment variable. There are also some example files in the code directory, but I'll unfortunately have to skip them. Last thing about fixtures. Sometimes you need to just do some setup inside a fixture. Maybe create a database or patch some things away. And you maybe aren't even interested in the value. So you just use it to have a nice place to put setup code. Now what you can do is pass autoUse equals true to pytest.fixture. And PyTest will automatically use that fixture for, like here for the whole session, or use it for every test without having to explicitly request it. You can still return a value and then use it maybe in some tests, but you don't have to. You don't have to have a DB argument for it to be used. So, wrapping up about fixtures, you can use them to inject resources into test functions, interact with those tests. You can manage the lifetime of those resources by caching. You can set up things implicitly using autoUse. And you can also rerun tests with different configured resources, which I couldn't show in full, but I hope you got a first impression of how things look. So, if I convinced you that PyTest is cool and you want to use it, how to migrate to it? Usually, if you use Unitest or the nose library or nose test runner, PyTest should run your existing test suite just fine. If it doesn't, that's often considered a bug in PyTest. So that's it's good to investigate what's going on. I would recommend, if you switch to PyTest, don't aim for keeping compatibility with Unitest or with nose, because then you can only use a small subset. You can't really use PyTest features. I'd prefer committing to it and only using PyTest, because personally, I mean, I'm a bit biased, but I don't think there's any downside to it. You need to install it, sure, it's not a standard library, but nowadays that shouldn't be a big problem. So you don't need to rewrite how your tests look. You can start using it incrementally, start using fixtures incrementally. There is, however, a project called Unitest to PyTest. Actually, there are 2 projects called like that. One is from Dropbox and not that good, and one is from the PyTest organization and better. So what that does is kind of a half-automated rewriting of all those assertions. You will still need to fix things up by hand, but it makes the process a little bit less boring. One thing I also couldn't really cover are plugins. there are hundreds of them for whatever purpose you need, really. So if you use some framework, say Django, for example, there's a plugin for it. Testing for Qt GUI application, sure, is a plugin. It's things like async.io, Twisted, there are plugins. Even if you have JavaScript or C++ code and want to test them with PyTest, there's a plugin. So you see some kind of pattern there. There are lots of plugins, and if there isn't a plugin for whatever you want to do, it's really easy to write one. All you do is you start by writing some plugin hooks. You can even put them in your conftest.py to start customizing PyTest that way. And whenever you are at the point where you have something maybe even usable for other projects, create a plugin for it. At that point, I should really give shout out to Cookie Cutter, which is a project giving you a template for a new project. So you can use Cookie Cutter and PyTest plugin template, and it will set up things for you. Like it will give you a setup.py which installs your plugin and all that. So it's really easy to get started and to start contributing even outside of PyTest of the core. Some plugins I want to highlight are Hypothesis, which is only half PyTest plugin. You can actually use it directly with Python even. What Hypothesis does is, because it's a property-based testing, so instead of writing tests, you tell Hypothesis, hey, give me some strings or give me some integers. And then I have some property which should always hold. For example, if I have some encode method and a decode method, I should be able to encode something, decode it again, and get back whatever I had at the beginning. So it's just like 2 or 3 lines of code. You call Hypothesis, it calls your tests with like some hundreds of values, and it's really clever about it, and finds issues you would never have found by hand. So I'm quite fascinated by that. I usually in the 3-hour version of the talk, there's an exercise about it, but I unfortunately also had to cut it out. There is PyTest instafail, which can be useful if your test suite runs more than a couple of seconds, because it prints the output immediately instead of printing it at the end. And all kinds of other reporting plugins. Want a Slack message when your test fails? There's a plugin for that. There are different plugins around repeating tests. For example, if you want to run a test 10 times for whatever reason, or want to write benchmark tests. As I said, there are integrations in all kinds of frameworks. There are integrations for the coverage and the mock library, which can also be quite useful. Coverage gives you an overview of what part of your codes are run by your tests and what part isn't. So it can give you kind of an idea of what needs more testing. And yeah, lots more. So that's pretty much it from my side. We will have maybe 5 minutes left for questions at the end. You can contact me here if you have any further questions and can't find me anymore or whatever. You can find out more about PyTest there. And I also did those workshops in companies. So if you think that would be a good fit for you or your company, please let's talk. Thank you very much.